Phishing is one of the most pervasive and costly cyber attacks, incurring over $26 billion in reported losses, and has significant implications to national security. Our project aims to identify and understand the network infrastructure that phishing attacks come from in order to improve detection of these emails. Phishing emails can take many forms, but usually attackers use social engineering to trick victims into giving up sensitive information. Current methods organizations use to stop phishing can be bypassed with not much time or cost, creating an urgent need for novel and more robust methods of detecting phishing emails. Our project aims to improve detection of phishing attacks by understanding where phishing emails originate from. We found that the computing infrastructure a phishing email comes from can indicate what strategy the attacker used. In phishing detectors, we can then target the most prevalent and damaging types of attackers. Next, we found that less than 10% of all senders at the IP level are sending over 80% of all phishing email. This implies that prioritizing stopping attackers from even just the top senders by IP address is an effective way to block a large amount of phishing attacks. Finally, using time series analysis, we found that attackers usually send phishing emails in short-lived bursts. Thus, we can use anomaly detection over the email sending traffic to identify these bursts of phishing email.
We have a data sharing agreement with Barracuda Networks. Barracuda provides email security for a large number of companies. And so our main data set is a large scale data set containing over 200,000 phishing emails and 2 billion clean emails, which encompasses all of the emails they received in January 2020. We performed a large scale feature analysis on the data after extracting the IP addresses from the email headers. With this information, we were able to join our dataset with external datasets, allowing us to analyze additional network features such as AS categorization, geolocation, and time series that allowed us to observe patterns for different types of phishing attacks.
The first challenge we addressed was identifying the useful sender information in the email header and extracting networking elements of the emails for analysis. Next, we addressed finding the network characteristics that best differentiate between clean and phishing emails. Some of these features included measuring the IP address chain length, looking at email protocols such as SPF and DKIM checks, and geolocating the sender's country. Finally, we aim to understand the distribution of phishing attacks across senders as defined by network characteristics. We built a data set of phishing probabilities of each sender in our data set by IP address and also by organization. Finally, we analyzed the email traffic over time of high-volume phishing senders and found that most phishing attacks coming from a particular IP address are sent in a short-lived burst. The graph shows one example of this.
There are several broader benefits of our project. Firstly, phishing is a complex cybersecurity attack and needs defenses that are multifaceted and robust. In 2019 alone, over $3.5 billion was lost to phishing, which is in addition to the high level of security risks from account compromise. Attackers regularly target organizations that we all rely on, such as hospitals, banks, and schools. Current classifiers primarily focus on the content of emails, which can be easily manipulated by attackers to bypass phishing detectors. However, network characteristics require much more technical knowledge, cost, and time to manipulate. Beyond improving current technology, our project contributes new insight on strategies used by phishing attackers. There have been machine learning classifiers that can do a decent job of identifying phishing emails, but those don't really help us understand the behavior of attackers. We aim to learn more about the different types of attackers, their strategies of phishing, and the overall scope and effectiveness of their methods. Lastly, our project recognizes the importance of responsible use of sensitive proprietary data. We took several precautions to ensure the security of the data we were handling, including the use of a laptop provided by Barracuda when receiving data and redacting personally identifiable information in any presentation of our results. Ultimately, the results of our project improve the defenses the cybersecurity community has against harmful phishing and will minimize the damage phishing will cause in the future.